Hello students, in this video I am going to go through and explain the occurrence or the manifestation of extraneous solutions, and in particular when we're solving square root functions. And as a matter of fact, these extraneous solutions do not just occur when we're solving for square root functions, but anytime we perform one particular skill. And let's take a look at what that particular skill is. So anyway, let's define what an extraneous solution is. So extraneous solution is basically a solution that doesn't make any sense. And I know that this is not a mathematical terminology, makes sense, okay? But it's rather than giving you a technical definition of what it is, I think it's sometimes better to work with to think about the working definition rather than the technical definition of things. Okay, so the extraneous solution. Okay, what happens is what makes something doesn't make sense. Does getting an imaginary answer, right, is that considered extraneous because that doesn't make any sense to you at the moment because it's just unclear what an imaginary number is? No, that's not what an extraneous solution is. As a matter of fact, the imaginary solutions, okay, they actually they do fulfill the conditions of an equation, of quadratic equations. So it's not like imaginary solutions are extraneous. They're not the same things. Okay, so what exactly is an extraneous solution? An extraneous solution is when you take that number and you substitute it back in. Okay, when you substitute it back in, things do not work out to be the same on either side of the equation. Okay, so let's say if you had f of x is equal to 0, right, and you solve for a solution. Let's say the solution turned out to be x equal to a, right? If you take this and put it back in here, it will not equal to 0. Okay, so in that case, even though you did all the work correctly, okay, and x equal to a came to be your conclusion, x equal to a is considered an extraneous solution. Okay, in the case of an imaginary answer, let's say if it was x is equal to like ai, right, and where you did substitute that back in and you ended up with something equaling to 0, right, then yeah, this works. Even though this is an imaginary number, okay, that would be considered a solution. Okay, so there's a difference between imaginary solution and an extraneous solution. Just want to be clear on that. Okay, so when you're an extraneous solution, the answer just doesn't make any sense. It doesn't fulfill the original condition of the equation that you're trying to solve. Okay. So can an imaginary solution be extraneous? Of course. So anytime when you have a solution where where it doesn't fulfill the original condition, that's considered extraneous. Anyway, so so let's take a look at another, or not another, but try to answer this question of the video, which is why does it even manifest itself? Like, I mean, is math meant to be like just confusing all the time? No, of course not. Let's try to understand why that happens so that it doesn't become confusing. Okay, so suppose we have f of x is some square root function and g of x is some other function. Doesn't have to be square root. Okay, so what happens is when we so again, let's just write that this is a square root function. And over here, this guy, g of x, doesn't have to be a square root function, but let's say one of them was, okay? So in order for us to solve for this, okay, what we would do is, we would square both sides. And again, I'm speaking in very general terms here because at this point in your understanding of algebra, you should be able to follow what I'm about to do. If I square both sides, okay, I end up with this quadratic looking thing, right? And I'm going to subtract both sides by g of x squared. Notice right now, okay, I don't know what f is, I don't know what g is, it doesn't matter, I'm speaking in very, very general terms, but what you do recognize is this expression right now, or this equation right now, is a difference of squares. This is factorable, isn't that right? Yeah, it is. This is indeed factorable. If it's factorable, I'll end up with f of x minus g of x. This is a difference of square, right? Times f of x plus g of x. So under what conditions will this equal to 0? It will equal to 0 if I end up with f of x is equal to g of x, or f of x is equal to negative g of x. Well, wait a minute. There's something contradictory that just took place. Well, what's contradictory is this guy right here. Right? The original problem statement was f of x is equal to g of x. Okay? And that is true, okay? That is, I mean, we came to the same conclusion with this guy right there, okay? So that is consistent. However, by the very act of squaring something, okay, we actually unintentionally created extraneous solutions, and these extraneous solutions does not work. And as a matter of fact, whenever you are raising both sides by any quantity, like by any power that is even, let's say to the fourth degree. Let's say if f of x here wasn't a square root function, but a fourth root function, right? Then you would have to raise both sides by the power of 4 to undo that fourth root, right? And in which case then you'll end up with, again, an equation that is a difference of square. However, this difference of square, okay, we can factor this twice, right? So we'll have f of x squared minus g of x squared, f of x squared plus g of x squared. And you'll end up factoring this even more, and you'll end up with, again, more extraneous solutions. Okay, we'll end up with a very, very similar situation as in the in the situation from before. Okay, when we factor this. So again, anytime you are raising both sides of the equation by an even power, so again, raising both sides, let me write it over here. Whoops. So raising both sides of an equation by an even power will create the possibility, okay, of extraneous roots. Doesn't have to happen all the time, okay, as we saw in the exercise video, okay. Even though we square both sides, sometimes we're able to we have it, and sometimes we don't, okay. But it is important, okay, when you are squaring both sides, that you do go back and that you check to see whether or not the solutions that you have makes any sense. Again, making sense is not a mathematical terminology, but you get what I mean, okay? Rather than giving you a technical definition, sometimes it is better just to work with a working definition. Anyway.